Welcome to Gravimetric Analysis Practice. I wanted to work through two problems that could be helpful on the quiz tomorrow, but I do want to encourage you to work through them yourself first. So if you have not worked through problem 1 yet, if you would pause the video and work through that now and then come back and take your work. I think that will be much more helpful than just watching me do the problem. In fact, I know that it will be much more helpful than watching me do the problem. So if you have not worked the problem on your own, again, pause and do that now. The question states that we have excess sodium nitrate, or sodium sulfate, and we're adding it to 42.53 milliliters of barium nitrate. The first question is, what is the precipitate? So we have sodium sulfate, Na2SO4, being added to BaNO3(2). You can see it's a double replacement reaction, which is going to produce sodium nitrate and barium sulfate. Now, sodium is a group 1 element, and nitrates are always soluble as well, so that is not the precipitate. This barium sulfate would be the precipitate. We need to balance with the 2 in front of the sodium nitrate. And the question does not ask you for the balanced equation. However, you know if it's a stoichiometry problem that you're probably going to need it. So it never hurts to have it. Also helps you to picture what's going on. So we know we have too much of this sodium sulfate excess, and we know we have 42.53 milliliters of this barium nitrate. Now it is a liquid, okay, a solution, and so we can't take barium nitrate and change it to moles using that 22.4. Be very careful with that. It's only for gases. The second question, so we've answered what is the formula of the precipitate. The second question tells us that 3.046 grams of the precipitate. Now we now know the identity of that. So instead of putting precipitate, we can say that that is our barium sulfate. Once formed, what is the molarity of the barium nitrate? We have this piece of information, the grams of the barium sulfate, but what we're really concerned with is the molarity of the barium nitrate. We know that molarity is moles over liters. We want the molarity of barium nitrate, we need moles of barium nitrate over liters of barium nitrate. We already have here the liters of barium nitrate, well, in milliliter form, but we can change that very easily to liters, 0.04253 liters. So by moving that decimal 1, 2, 3 places to the left, milliliters can become liters. So we have our liters, but we need our moles of barium nitrate, and we have this key piece of information, 3.046 grams of barium sulfate. I'm just going to do a mole map to get to moles of barium nitrate. Okay, that's my goal because that's what I want to know the molarity of. I'm starting over here at the mole-to-mole part just because I haven't calculated my molar mass yet. So I went ahead and wrote that in. And going back here, 3.046 grams barium sulfate times 1 mole over the molar mass of barium sulfate. So barium is 137, sulfur 32, and oxygen times 4 should be 64. So I got a total of 233 grams of barium sulfate. So I have 1 mole over molar mass, goal over given. Now I'm going to do the math. I'm stopping at moles again because I'm looking for the molarity. So 3.046 divided by 233 times 1 divided by 1. 0.0131 to 366 moles of barium nitrate. So I'll insert that here, 0.013 moles, and I can divide to find my molarity. So 0.013 divided by 0.04253. That's a molarity of 0.306 molar. Okay, so again, look at what your question is asking. First, what is the precipitate? We wrote a balanced equation and identified the thing that would be insoluble. Then, They told us that we had 3.046 grams of that precipitate. We started with that and went to moles of our unknown, barium nitrate. We were asked, however, for the molarity, so we took that moles and divided it by the volume, which was given in the first sentence. Make sure your moles and your volume match, that they're at the same compound. All right, so that's number one. Number two, a slightly different problem. If you have not worked this yet, pause and do so, and then come back and watch me work it. Again, you need to work things on your own first. So we have a 5 gram sample of the mixture. It has strontium nitrate and potassium bromide are both in the mixture. So we keep seeing these mixture problems. First we saw them in the lab with our potassium bicarbonate, potassium carbonate. We've seen them a lot here in this section. So we don't know how much strontium nitrate or how much potassium bromide. All we know, and we can say this shortly, is that strontium nitrate and potassium bromide are going to equal 5 grams if I added them together, their masses. Okay, but that's all I know at this point. Excess lead nitrate solution, lead nitrate, formula given, is added to precipitate out 0.7882 grams of lead bromide. Now notice what happened. Lead nitrate was added to the mixture. We must identify, what did the lead nitrate react with? Well, it made lead bromide, so it must have reacted not with the strontium nitrate, because strontium is not mentioned, or nitrate in the product. It must have reacted with potassium bromide, because I see bromide in the product. So it must have formed lead bromide, that was given, and then potassium nitrate. Now notice, potassium nitrate is a spectator because those are soluble things. So that's why they don't talk about that necessarily in the product. So here we have a balanced equation with a 2 in front of the potassium bromide. All right, let's go back to the question. We have this information, 0.7882 grams of lead bromide. 0.7882 grams of lead bromide. Then the question goes on to ask me, what is the percent by mass of potassium bromide and what is the percent by mass of strontium nitrate? The only thing I know for sure is that I have 0.7882 grams of potassium bromide. And the only thing that relates to is, I have 0.7882 grams of lead bromide. The only thing that relates to is the potassium bromide, not the strontium nitrate. Strontium nitrate was not involved in the creation of the precipitate. Okay, strontium nitrate is not mentioned in the precipitate, so we cannot calculate it from here. Alright, so 0.7882 grams lead bromide. I'm going to go from here to grams of potassium bromide because I'm asked for percent by mass. This is different from the last problem where we asked for molarity, so we stopped at moles. Percent by mass. So I'm going to go 1 mole over the molar mass of lead bromide. Lead bromide, lead. 207 for lead plus 80 for bromide, but 80 times 2. So I got 367 grams. Alright, I'm looking for potassium bromide. It's a 2 in front of potassium bromide in my balanced equation. Notice I could even get that from here. There's 2 bromines in lead bromide. So I must need a 2 and then 1 lead bromide. And then I'm running into my balanced equation here, so I'm going to erase the beginning of it. Finally, the molar mass of potassium bromide, 39 plus 80, 119 grams over 1 mole. So 0.7882 divided by 367 times 2 times 119. I got 0.5, let me do that one more time, 0.7882 divided by 367 times 2 times 119. 0.511 grams of KBr. Now, what's the question again? Percent by mass of potassium bromide in the mixture. So potassium bromide divided by the mixture. Potassium bromide in the mixture. We know the original mixture was 5 grams of the mixture. So we want to do percent. Potassium bromide divided by the mixture times 100 should be a little over 10%. 10.22% or 10.2% KBr in the mixture. Alright, so that's potassium bromide. We took our balanced equation, we took our mass of our precipitate, lead bromide, went to potassium bromide, got 0.511, divided by the total mixture, 5 grams, multiplied by 100, 10.22% potassium bromide. Now the next question asks us for the percent by mass of strontium nitrate in the mixture. Well, if you think about it, there's only 2 things in the mixture, as we said before. Strontium nitrate and potassium bromide, and they're going to equal 5 grams. Remember this comment above. So if we know our mass of potassium bromide, we can find our mass of strontium nitrate just by subtracting. So 5 grams, our original mixture, minus the lead nitrate, the potassium bromide, must equal the strontium nitrate. So 5.00 minus 0.511. So this is 4.489 grams of the strontium nitrate. Again, they want the percent, so I'm going to do 4.489 grams divided by total mixture times 100. 4.489 divided by 5 times 100, get 89.8% for the strontium nitrate. Now notice, we could have definitely taken a shortcut here. 10.2 and 89.8 add up to 100. So we could have just said, well, the potassium bromide is 10.22%, so the strontium nitrate must be 89.8%. Or we could have done like we did, subtract from your total 5 minus the potassium bromide equals the strontium nitrate. Divide by your total times 100 equals. Okay? So those are your 2 percentages. This is different from molarity. Here it is percent. So grams over grams of the whole times 100. Alright, so if you have questions, watch back through the video again. That's probably not a bad idea anyway. And then if you're still a little confused, feel free to text me any questions that you have. And I hope this helps you prepare for the quiz tomorrow. Make sure you know how to do gravimetric analysis in the lab, what steps you would take, and then make sure that you can do the math for either type, whether you want percent by mass or molarity. Good luck!